This is the beginning of Module 4, Optimal Resource Extraction of Non-Renewable Resources. The agenda for this short presentation is profit maximization in perfectly competitive markets and Hotelling's rule, profit maximization in competitive markets when resources are finite. First, what is a non-renewable resource? There's two types of resources, a non-renewable resource and a renewable resource. The non-renewable is a resource with either zero or very low rate of natural replenishment, such as earth minerals like copper, aluminum, iron, fossil fuels like oil, natural gas, or nuclear. Renewable resources are resources that are naturally replenished, like sunlight, wind, oxygen, water, biomass, animals, etc. With non-renewable resources, production is constrained by the quantity of the resource. It's not replenished, so there is a finite reserve of the resource. How do firms in perfectly competitive markets choose quantities to maximize profits? Well, they choose quantities that they choose a quantity that sets price equal to marginal cost. So this is without a finite resource, just a general perfectly competitive firm. Choosing Q such that P equals marginal cost does not always maximize profits for price-taking producers of non-renewable resources, however. When there's a reserve, it's slightly different. So here's our simple graph of a perfectly competitive market with a marginal cost curve equal to 10 plus 2Q. The price is equal to 110. So in this case, the price is equal to our demand curve. Let's suppose this is the optimal choice of quantity for the owner of a small chair factory or a price taker. The intersection of these two curves is 50. So that's the optimal production quantity at a price of 110. The producer surplus for the chair manufacturer is everywhere under the demand or the price down to the marginal cost curve, or the area shaded here in green. Now consider the case where there's a finite reserve of the good being produced. In this case, we're dealing with chairs, so there is no reserve. There's no finite stock of chairs. We can produce as many chairs as we want. But what if we had a situation where the inputs to the chair manufacturing process, like wood, were finite, or we have a coal mine and the stock of coal in the coal mine is finite. Consider that and take the quiz